All right, today we're tackling two of the most critical and honestly, most confused concepts in all of tech: latency and throughput. They're basically the two secret ingredients that decide whether an app feels amazing or, well, terrible. So let's get into it and figure out what really makes our digital world tick. So picture this. You've paid for that super fast, top of the line internet. You're ready to go. But then you jump into your favorite game and you're lagging. It's so frustrating. But why does that happen? Well, this exact problem is the perfect way to understand our topic today, because the answer is all about the difference between latency and throughput. Not all speed is created equal. Okay, first up, latency. Whenever we complain about lag or talk about our ping in a game, what we're really talking about is latency. At its heart, it's all about the speed of a single, individual action. Now, if you crack open a textbook, you'll get a definition that looks something like this. It's the time it takes for one tiny little piece of data, a packet, to travel from point A to point B. From your computer to the game server and back. Seems simple enough, right? Well, not so fast. Because that network travel time, it's really only one small piece of the puzzle. For the people actually building these applications, the real bottleneck, the thing they really worry about, is what happens when that data packet arrives. It's the server's thinking time. See, the total latency that you experience is made of two key parts. First, you've got that network latency we just mentioned, the travel time. But then you have processing latency. And this is the big one. This is the time the server spends actually doing stuff, looking up your user profile, running calculations, fetching data from 10 different places. And here's the kicker. A lot of the time, this thinking takes way, way longer than the travel. So given how important this is, how do engineers actually measure it in a way that's, useful? Just saying your average latency is okay, but it can be super misleading. You have to go deeper. So instead of just looking at the average, pros look at percentiles, specifically things like P90 and P99. P90 just means that 90% of requests were faster than that number. And P99, you guessed it, 99% were faster. These numbers tell a much, much richer story about what your users are actually experiencing. So why obsess over this? Because that P99 number, that's the experience of your unluckiest 1% of users. Is their experience just a little slow, or is the app completely unusable for them? This is how engineers find the true breaking points of their system, and it's how they set smart alarms. So if that P99 number suddenly shoots up, they know something's wrong before everyone starts complaining. So to wrap up this whole idea, if you remember just one thing about latency, make it this. It answers the question, how fast? How fast can a single task get done from the moment you click the button to the moment you see the result? Okay, let's switch gears. If latency is all about speed, its partner, throughput, is all about capacity. It's about volume. It's the other, equally important, side of the performance coin. Now, the classic definition of throughput is probably something you've heard before. It's how much data you can push through a pipe in a certain amount of time. When your internet company sells you a 100 megabits per second plan, that number, that's your throughput. It's also called bandwidth. But just like we saw with latency, that definition is really focused on the network pipes. When we're talking about how a server is performing, we're not just shoveling data around. We're handling specific actions, specific requests from users. And for that, we use a much better metric, TPS, which stands for transactions per second. It's exactly what it sounds like. How many things, like loading a web page, posting a comment, or searching for a product, can the system handle in one single second? That's the real measure of capacity. And there it is. That's the core idea. If latency is how fast, throughput is all about how much. How much work can your system juggle at the exact same time without dropping the ball? So this brings us to a really practical question. What do you do when you need more how much? When your app gets popular and suddenly you have way more users, you have to increase your throughput. So how's that done? Well, engineers have two main tools in their toolbox. The first one is pretty intuitive: horizontal scaling. You just add more servers, more machines to share the work. But the other, more powerful tool is to increase concurrency. That means you make each individual server smarter, so it can handle more requests at the exact same time. Let's make this really visual. Imagine you start with one server. It can handle one transaction per second, so your throughput is 1 TPS. Simple. Now, if you scale horizontally and add 4 more servers, what do you get? 5 servers, 5 TPS. It's a straight line. More servers, more capacity. But now, watch what happens when we use our second tool. We take those same 5 servers, but we boost their concurrency. We let each one handle 15 requests at once instead of just one. Suddenly, our capacity explodes. We jump from just 5 TPS all the way up to 75 TPS. This is the secret sauce. This combination is how modern websites handle millions of users. And here's a quick pro tip, straight from the source. You can't just crank up concurrency forever. A really good rule of thumb is to aim for about 80% peak CPU usage on your servers. This pushes your hardware to work efficiently, but it leaves you just enough headroom to handle a sudden spike in traffic. It's that perfect balance between power and safety. And you've definitely run into this in the real world. Ever used a service that has a rate limit? Well, that limit is literally a throughput cap, measured in TPS. So when a developer asks a company like Twitter for a limit increase, what they're really asking for is a higher TPS allowance for their app. Okay, we've looked at both sides of the coin. Now it's time for the main event. Let's put them side by side and make sure the difference is absolutely crystal clear. This table just nails it. Latency asks, how fast? And we measure it in units of time, like milliseconds. The best analogy is the speed of a single car on the highway. Throughput asks, how much? And we measure it in requests over time, like TPS. And that's like asking how many lanes the highway has. See? You can have a super fast car, that's low latency, on a tiny 1-lane road, that's low throughput. Or you could have a massive 10-lane superhighway, high throughput, but all the cars are stuck in traffic and moving slowly, high latency. So let's go all the way back to the beginning. For that online game, what do you need? You need low latency, right? You need your actions to feel instant. But for something like a file download service, you need high throughput. You want to move as much data as possible, as fast as possible. And knowing which one of these to prioritize for your specific problem, well, that's what system design is all about.